in this case, we have a problem of free fall, right? We have a free fall problem here. And they say a rock is tossed straight up from ground level with a speed of 20 meters per second. So when it returns, it falls into a hole 10 meters deep, right? So first, they say what is the rock speed as it hits the bottom of the hole? Okay. And then they say how long is the rock in the air from the instant it is released until hits the bottom of the hole, right? So basically, this is what my problem is about. So what happens, with these problems? Remember what we said about the free fall, right? We said that we have, free fall when there is no air resistance, okay? So when the only force here is the attraction of the Earth, right? So we know that the acceleration of the gravity in these problems always point downward. So the acceleration here is the acceleration of the gravity that always point downward. Okay. Now, what is my problem? I have here this hole that have 10 meters deep. And I will throw, in this case, a rock. The rock will go up. It will reach here, a position where its velocity would be 0. And it's going to start falling down. And then, as we don't have a resistance, right? I will call this initial velocity. I will call this velocity at point A, where the point A will be the point of, the highest point in the trajectory of the rock. And I will call this point B. And the velocity in B is equal to the initial velocity, right? So basically, this is something that we can always assume, when we have these kind of problems. I throw the ball up, right? This is just moving against the acceleration of the gravity. So it's going to be losing velocity at what rate? At 9.8 meters per second, right? Because this is the acceleration of gravity. So this ball or this rock, when it's moving up, is losing its velocity at a rate of 9.8 meters per second. And when it starts falling down, it starts gaining velocity now at what rate? At 9.8 meters per second. So the acceleration moving up and the acceleration moving down in magnitude is the same, in direction they are opposite, right? When this moving down, the velocity points up, while the acceleration points downward. When it's moving downward, the velocity points downward and the acceleration points downward. So basically, the velocity at point B is exactly the same velocity, that we had when the ball was tossed up, right? So what is going to be the velocity at point B would be the same 20 meters per second that I had over here. So what I want to find what is the rock speed, when it hits the bottom of the hole. So I want to find, if I call this point C, I want to find the speed of point C. This is what I don't know. But what I know what? The distance that exists from B to C. And I know the acceleration, that is the acceleration of the gravity, right? So I can say that BC squared, that is, it would be equivalent to the final velocity, right? Is equal to BV squared, right? That this counts as the initial velocity square, right? Plus, and y positive, because it's moving, the velocity and the acceleration are in the same direction, it's moving downward. So the velocity is in the same direction that the acceleration, plus 2 acceleration, what is g in this case, so g counts as acceleration here, delta y, I will call this delta y. And we say that this is delta y, the 10 meters. You know how deep is the hole? I will just call this delta y. So what I want to find is this BC, right? So I know that this will be 20 meters per second square plus, this is BC square, right? 20 meters per second square plus 2 times 9.8 meters per second square times 10 meters, right? So if you calculate this and you find the square root, we have the BC would be, in this case, approximately 24.4 meters per second. So what is approximately, you know, 24 meters per second. And that would be the velocity where, at this point, you know, when the rock hits the bottom of the hole, right? Remember that you had here this square, so you have to find a square root for this, for all this value over here, right? So here, BC stands for, you know, the final velocity, or the velocity when it's hitting the bottom of the hole. BV squared stands for, you know, the initial velocity, or the velocity when it's falling down at the level of the ground here, you know, 10 meters above the bottom of the hole. And G, the acceleration of gravity, stands for, you know, the acceleration that we have in the formula. Remember that the formula is BF squared is equals B initial square plus 2A delta X or delta Y, depending if we have motion in the X direction. I will use delta X. If I have a motion, you know, in vertical direction, I will use just delta Y, you know, any change in position. Look at how they say now here. How long is the rock in the air from the instant it is released until it hits the bottom of the hole? So now we want to know what is the time of flight of this rock, right? So in this case, we want to find the time that takes the rock to fly, reach the maximum point in the trajectory, the highest point in the trajectory, and then to fall down until reach this point. So this is the time of flight, right? This is the total time, you know, that the rock is in the air. So now we have here a time, and we just split the problem in two parts. I will split the time in two parts. One part that we call time going up, right? There is a time from this point to the highest point in the trajectory, and then the time going downwards, going down. So I know this time of flight will be the time going up plus the time going down. Now, my question is, if we know the velocity, right? And we know the acceleration, that is the acceleration of gravity, we can easily find the time, right? What formula do you recommend me to use to find the time in this case? We know the initial and final velocity, and we know the acceleration, that in this case is the acceleration of the gravity. So to find the time flying up, right, what formula do you recommend me to use? Any answer? Any
So
recommendation?
we have the initial, the acceleration.
Okay. So I have this initial velocity here. I have the final velocity here. And I know that regardless if it's flying up or down, we have the acceleration here. That is the acceleration of the gravity, that is G. Okay.
And we're trying to find
and
time.
we're trying to find time.
Okay. So I think the shortest one, which is V initial plus acceleration times time equals final.
Plus acceleration time. So this one should be the formula to use, right? Because
maybe, yeah.
Because we know what? We know the initial and final velocity. We know the acceleration. Now, what is the only issue that we have to keep in mind in this case? You know, that the acceleration in this case is negative, is in this case minus G, right? This is for when it's going up, okay? So this becomes into BF equals B initial minus GT, right? Now, what is the point here? What is the final velocity? The velocity at the highest point in the trajectory is 0, right? So this final velocity here is 0. So I can just make this equal to 0, and I solve and I get B sub 0 equals GT. So B sub 0 over G equals T. So T equals, what is B sub 0 in this case? 20 meters per second divided by 9.8 meters per second square. That would be the answer in seconds. And the answer in this case would be 2.04 seconds. I will round at the end, right? I will round at the end when I find the total time, okay? To 2 decimal places, right? I mean, to 2 significant figures, right? Now, we found the time when it's just going up. Now, what about the time when this is just moving downward now? Now, this final velocity, when it's moving downward, becomes the initial velocity of the downward motion, right? And then, what is going to be the final velocity? The final velocity will be the velocity when it's hitting the ground here, right? So now, for the second part of the problem, okay, this is not my final velocity anymore. That would be my initial velocity, because what I have now, where is my, okay. What I have now is something like this. I already have the rock at this point, where it has now an initial velocity, 0, is falling down, right? So now the velocity is like this, right? And the acceleration is also like this, right? So now it's not minus G, now it would be plus G, right? And what is the velocity when it's touching this point, when it's hitting the bottom of the hole? We found it. It's which one? It's this value, right? That we found in the previous part of the problem. it was really 24.4. So we use 24.4, you know, and we use this value. So I know the velocity here in the bottom, that is 24.4 meters per second. And I know the velocity at the highest point in the trajectory, there is 0 meter per second, right? So remember, what was my final velocity while my rock was moving up here becomes now in my initial velocity when the rock is falling down, okay? So look at this, as I have split this in before reaching the highest point of the trajectory and after reaching the highest point of the trajectory, because there is where I have, you know, the turning point. That is the turning point, because there is where the velocity change its direction, right? So I just I divide my problem in two parts. Flying up, and we find the time. Now, time by just falling down, right? And what formula can I use? Exactly the same one, because I have again initial velocity, I have again final velocity, and I have again the acceleration, right? So I can say that BF squared, sorry, BF squared, no, BF is equal B initial plus acceleration time. Now this acceleration, in this case, is positive G, okay? Because the motion is downward. So BF, I know that this B sub zero, this B initial is zero. So B final will be GT. So B final over G will be T. So what is B final? Is 24.4 meters per second. I mean, this value over here that I found in the previous step of my problem, you know, in the previous, in the first part of my problem. So 24.4 divided by what? By 9.8 meters per second square. When you perform this calculation, you will get that the time falling down is 2.49 seconds. So now I'm ready to find the time of flight. There is the time going up plus the time going downward. What is that? Going up 2.04 seconds plus 2.49 seconds. This is 4.53 seconds. And 4.53 seconds will be 4.5 seconds. And this is the time of flight. So I found first the time, you know, going over, the time when it was just, the road was just going downwards, right? Falling down. And then I finally found the total time, the time of flight, the time that the rock was in the air. You know, that is the sum of both times, the time going up plus the time going down. Okay,